Hello, I'm Ivan and I'm going to tell you about applications of uncertainty estimation techniques for machine learning. Let's look what we already know. In the previous videos we introduced you to the world of uncertainties. We showed you that uncertainty estimation is crucial for decision-making systems such as self-driving cars, stock markets, or medical diagnosis. When there is no clear metric to optimize or environment is very risky, where even for a human a solution is not clear. In these cases, uncertainty estimation comes and builds trust between machine learning models and humans. We have discussed difference between data and knowledge uncertainty. High data uncertainty means complex decision-making process like less overlap, while high knowledge uncertainty means that the model did not see such example in the train set. We also have discussed ensemble methods for uncertainty estimation, different ways to generate ensembles and use them. For example, here on the slide you can see behavior of Gaussian ensemble for different uncertainty cases. And we have also discussed methods to assess uncertainty quality, how to understand if your uncertainty works well. Even more information you will see later in our videos. Generative approaches, distillation, and active learning. Now you may ask yourself, okay, nice, research methods, but how should I use it? Where are real production examples? I'll help you. Now I will introduce you 3 real working examples of uncertainty estimation techniques in production. Let's look at the first case about automatic laser metal welding. There is a company that performs automatic welding of some metal parts, for example pipes. It has a quality control that was performed by engineers. In most cases welding is good and nothing should be done, but in several % of cases welding is bad and such details should be dropped. You can build a machine learning algorithm to automate the process, but it should have 100% precision, as a metal part could be an important part of some car or plane. With usual machine learning, it is hard to build a trustworthy system to achieve such quality. Uncertainty estimation can help us solve this problem. By using uncertainty estimation algorithms, we can trustfully predict how confident our model is, and based on that, calibrate our system to have 100% precision on confident predictions, while uncertain predictions will be processed by engineers. By installing uncertainty estimation, we improved performance of the system, saved 70% of engineers' time, and have created a trustful system to assess welding quality. Let's move on. The same schema could be used even more smarter by incorporating the abilities of modern data assessment systems. For example, Yandex token assistant Alice. It uses automatic speech recognition algorithms to understand human voices. But sometimes signal is too noisy or out of domain for that system, and it produces bad output. We can install uncertainty estimation system on top of ACR system, and this will allow us to understand if the ACR works well and translation recognition quality is good. And if we have a good quality, then if we have a bad quality, then uncertainty estimation system will throw a signal to crowdsourcing system, such as Yandex Toloka, in order for people to translate signal into the text. Afterwards, this trained data is going to ACR system to improve quality and to make user happy. Now we can look at the results of uncertainty estimation in speech recognition. We removed bad outputs and improved the user experience of using Alice. We also created a framework to train our algorithm on complex cases. And finally, we use assessor's power very effective. Let's move on to the third case about object detection and active learning for autonomous driving. Suppose you have a fleet of autonomous cars, and you want to improve your neural networks with additional training data collected through these cars. For example, you want to find cars with bicycles attached at the back, or nighttime images with people on the road. So you need to find such images, save and annotate them afterwards. Simple calculations show that annotations for a fleet of 100 cars driving 8 hours per day would require more than 1 million labelers to annotate all frames from all cameras at 30 fps for object detection. But Tesla has much more cars, hundreds of thousands of them. So this is impractical. That's why we need to find necessary images in real time and annotate only them afterwards. This approach, when we choose the best training data from a large pool, is called active learning. And the best data is usually the most challenging data for current neural network system. That's why we need uncertainty estimation here, because it allows us to understand what network does not understand and what should be improved. NVIDIA and Tesla uses ensemble methods and uncertainty estimation techniques to find challenging objects on the images. They save such images and afterwards provide them to labelers. They collect label data and add it to their training sets. This improves system quality. Let's go through results. Here, active learning allows scale solution that would be impossible without it. It improves quality of object detection for autonomous driving. And according to NVIDIA study, this approach of finding appropriate images with uncertainty estimation even works with 1.4 times better accuracy of finding necessary objects than a human. That's all for now. If you have any questions, feel free to contact me and watch our uncertainty track. Thank you for your attention.